Our last group of functional groups are amines and amides. These ones are a little bit different. They all contain, or they both, sorry, contain a nitrogen bonded to the rest of the carbon chain. So we're going to take a look at what they are. So you can see my general groups up there, NH2, NHR, or NR2. So what do those actually mean? We actually classify them as primary, secondary, and tertiary, depending on how many alkyl groups are attached to the nitrogen atom. So more specifically, if you have a primary amine, you have one alkyl group and two hydrogen atoms. Secondary amine has two alkyl groups and one hydrogen atom. And a tertiary amine has three alkyl groups attached to the nitrogen atom with no extra hydrogens. So if we take a look, here are three different examples. One's a primary, one's a secondary, one is a tertiary amine. I want you to note a couple of things. Nitrogen is actually going to make 3 bonds, not 4 like carbon. So it always makes 3 bonds, and remember it's got that lone pair of electrons. We're pretty much going to ignore the lone pair of electrons. We're going to assume no coordinate covalent bonds are being formed. But nitrogen is going to be bonding to 3 things. So if that nitrogen is bonded to 1 carbon and 2 hydrogens, it's a primary amine. If the nitrogen is bonded to 2 carbons, it's a secondary amine. And if the nitrogen is bonded to 3 carbons, it is a tertiary amine. All right, so how do we name them? If we have a primary amine, the rules are as follows. You consider each molecule as an alkane, and the NH2 group, you're going to call it an amino group. The location is indicated, and the amino group is always given the lowest number possible. When you have more than one amino group, you have to use the prefix diamino. If there's 3, it's triamino, just like alcohols. And here's an example. Oh, I already have the answer up there. Okay, so this is a 2-carbon chain with an amine group attached to it. Okay, so we name the parent chain. In this case, it's 2 carbons. We get ethane. And then we have an NH2 group attached to it, so we call it aminoethane. We don't need to write 1 aminoethane because there's really only one spot you can put that nitrogen. If you ended up putting it on the other carbon, it's still 1 aminoethane. So there's one example. When we have secondary and tertiary amines, the rules are a little bit different. You identify the longest hydrocarbon group that's attached to the nitrogen atom. That's your parent alkane. Step 2, you name the other alkyl groups attached to the nitrogen atom. But instead of position numbers, you're going to use the letter N to locate the group. So the N tells me that that branch is located off of nitrogen and not off the main chain. If you have 2 identical alkyl groups, you're going to use N, N. Same as when we did like 1,1-dimethyl. So let's, we put the name together. You have your prefix plus your alkyl chain and then the whole amino alkane. So let's do a few examples here. So this first one is a nitrogen bonded to 1 carbon. So that is a primary amine. So when we look at that, aminomethane. So 1 carbon is methane, and there's an amino group on it. Okay. My second example is, again, a primary amine. Okay, it's a nitrogen bonded to 1 other carbon. But now my carbon chain is 4 carbons long, so that's butane. And now you have to tell me which carbon this amino group is on. Should be on the lowest possible number, so we'll number it like this: 1, 2, 3, 4. And when you do that, you get 2-aminobutane. This next one's going to be named differently because you have 2 carbons attached to your nitrogen. So this is a secondary amine. So you identify the longest carbon chain. It's right there. Then you've got your amino group attached to the second carbon, so if we call that 1, 2. And then a methyl group attached to the N. So when we put all that together, we get N-methyl and then 2-aminopropane. So again, if you start at the end, here's your propane. That was your 3-carbon chain, and you had an amino group on carbon number 2. Now all you have to do is tell me, so that basically named this whole part of the molecule. To do what's attached to your nitrogen there in green, you write N-methyl to say that it's attached to the nitrogen. Okay, and your last one down here, this is a tertiary amine. So this one's a little bit different. Oh, sorry, no, this one's also a secondary amine. Only 2 carbons. There we go. So we find the longest carbon chain here. Okay, that's 1, 2, 3, 4, 5 carbons long, so it's a pentane. And the nitrogen is attached to the end. Then you have an ethyl group on the other side of your nitrogen. So, oh, that's wrong. 2,2-dimethyl and ethyl. I'm missing something here. Oh, it's because of the branches. I'm sorry. So we actually have a carbon here with 3 carbons off there. It's not just a straight chain. Ah, that didn't work. So when we look at this, this is actually a 3-carbon chain with 2 methyl groups on it. That's how I got my 2,2-dimethyl. And then on the other side of my nitrogen was an ethyl group. So that's how I got that. Properties of amines. The carbon-nitrogen bonds and the nitrogen-hydrogen bonds are very polar. Thus, amines are usually quite polar unless you have a very long hydrocarbon chain. The presence of one or more nitrogen to hydrogen bonds allows hydrogen bonding to take place. Amines with low molecular masses are completely miscible with water, again because we have the hydrogen bonding in a very polar molecule. Boiling points of primary and secondary amines are higher than the boiling points of tertiary amines because in tertiary amines you don't have hydrogen bonding happening. And amines have slightly lower boiling points than alcohols. Amines are found widely in nature. We see them very naturally, especially when we start to look at proteins and stuff like that. All right, examples of amines. Adrenaline is the hormone produced by the human body under stress. Amines with low molecular masses have a fishy smell. They're also responsible for odors of decay and decomposition. They're weak bases like ammonia that can accept a proton because of those 2 extra electrons sitting on the nitrogen. This explains why vinegar and lemon juice, which are acids, can neutralize the fishy smell of seafoods, which is caused by your basic amines. So that's why a lot of people like to put lemon on their fish. All right, the preparation of amines. Here are some reactions. If we react ammonia with an alkyl halide, we make an amine. The products can be separated in the end by fractional distillation due to the differences in boiling points. So let's look at what happens in each one of these circumstances. Here I've got ammonia. When this bonds to, remember this is your rest of the carbon chain, so when it reacts with a carbon chain that has a halogen, remember this is a halogen, what actually ends up happening is the halogen and an NH2 group from here basically switch spots. So now, here's my R. Now I have an amine because I have NH2 on here. The other H stayed off here and ended up bonding with the halogen to make a hydrogen halide. So the same thing is going to happen. Here is an example of, again, the same chain, an organic halide. Okay, so there's your halogen reacting with, in this case, we have a primary amine. What's going to happen here? Again, we're going to basically take the H and the X. They're going to come together to make your HX molecule over here. And then that nitrogen is going to bond over here to the rest of the chain. So that X is gone, the nitrogen can bond. So that's how I get the nitrogen in the middle of the rest of the chain. But this nitrogen still has that hydrogen on. That's what I drew down there. If you have an organic halide reacting with a secondary amine, where's my answer there? You end up with a tertiary amine. Okay, so this is an example of a reaction that can actually just keep on happening step by step. So if we keep adding more and more of this organic alkyl halide, if we keep adding that to your products, you can end up by basically you keep adding on that alkyl halide to the different hydrogens on the amine until you have a tertiary amine. All right, amides, last functional group. This is basically a combination of an carboxylic acid and an amine. When they bond together, you get this fancy C double bonded to an oxygen and a nitrogen. So when we name amides, step 1, locate the part of the amide that contains the carbonyl group, okay? Just like when we were naming esters. You name the parent carboxylic acid that this part derives from. The carbon always gets carbon 1, the one that has the C double bond O. Replace the oic acid of the parent acid with the suffix amide and decide whether the compound is primary, secondary, or tertiary. So, if you have a primary amide, you need no prefixes. If you have a secondary amide, you have to name the alkyl group and again give it the location N, saying that it's attached to the nitrogen. And then same thing with tertiary amide. You need to use the location letter N instead of a number to tell me that the group is attached to the nitrogen. And you put the name together, prefix plus root plus suffix. So let's do some examples. So the first example, if I were to sever this off and have an OH group on here, this is what you should do. It's one carbon. That would be methanoic acid. So I'm ignoring the NH2 completely. My rule is when an NH2 is bonded there, so I have to erase that, we drop the oic acid and we add amide at the end. So what do we end up with? Methanamide. Second example, exact same thing, except now I've got two carbons. So I'm going to change from ethanoic acid to ethanamide. Third one, oops, sorry, down here. Third one's got three carbons. So that's propanoic acid, propanamide. Let me just move this over here. Okay. Third one, now we're getting a little complicated because now we have a secondary amide. We've got a nitrogen with two carbons attached to it, whereas up here we only had one carbon. So now what we have to do is we name the parent chain. That's still propanamide. Now we have to say that, hey, look, on the other side of this nitrogen, I've got a methyl group. So what do I write? N-methyl propanamide. Last one here. This one's a little bit tricky. Again, you're going to break the bond here. This is your parent acid. So again, it's going to be a propanamide. We're going to change the ending of propanoic acid. Okay, to the ending has to be amide. We have a branch on here. It's on the second carbon, so that'll be a 2-methyl. And then we also have another propyl group attached to the N. So it's going to be N-propyl. So we've got to put all that together. N-propyl, then 2-methyl propanamide. So always put the N first. And then the 2-methyl actually, because the methyl is actually attached to that propane, you put those together. So that's why the N part has to go first. And you're done. Properties of amides. We have very polar bonds again. Primary amides have 2 NH bonds, so therefore they're even stronger hydrogen bonds than carboxylic acids. Amides are very soluble in water. Primary amides, have much higher melting point and boiling points than carboxylic acid, so they're actually the highest. Acetaminophen, which is a common painkiller, that's an amide, main component to many painkillers. Urea is another example of an amide. It was the first organic compound to be synthesized in a laboratory. All right, preparing amides, condensation reactions. Hey, guess what? These are the last reactions that you need for your flowchart. So, description, it's a reaction between a carboxylic acid and ammonia, or with primary or secondary amines, also organic bases. What happens? You make an amide and water. So, this is very similar to how an ester was formed. You're basically going to remove water. So there's my H2O, I'm going to remove that. This nitrogen is now going to bond to that carbon. And we get your amide group, plus water at the end. Amides themselves can also undergo hydrolysis, just like esters. The hydrolysis of amides produces a carboxylic acid and an amine, so it's the exact reverse of what I just showed you. You need a basic or acidic hydrolysis, so both can happen. Here's an example of an acidic hydrolysis. So basically what's going to happen is we're going to cleave this bond here. You have to know that that's the bond basically that gets broken. You're going to take an OH off of your water here, and add it to make your carboxylic acid. That's how I got this part here. The rest of it, NH and CH3, that's here, but my other hydrogen from my water is what's going to make that NH2 so that my bonds are all stable. All right, so your flow chart should now be complete. We added in amides down here and hydrolysis and condensation to make it. Okay. We also have to add amines up here because when you add ammonia to an alkyl halide, you can make an amine. So that's it. That's all for functional groups. Next week, we're going to look at your addition and condensation reactions to make polymers.